This is the teardown procedure for the Fleck 2900S valve. This valve has a lot of options, so we're going to show you 3 examples showing some of the options available. This particular unit shows our 12-day mechanical time clock. As we move to the rear of the unit, we can see where our inlet, outlet, and drain locations are. This will be the same for all of the models. This unit does not have any injection system on the top, so this would be our filter version of the valve. The next unit we have has a lot of options on it. It begins with our electronic NXT controller. As we rotate to the back, we can see that this unit has an opening in the back. This is our treated water regeneration option. We can also see that we have an injection system at the top. This cap at the top shows that this is an upflow unit. You can also notice this because the injector is closer to the back plate. As we follow the tube around, we can see that this unit has the plastic 1710 brine valve. Our third example is a 2900S. It also shows the electronic meter, but with the optional blue cover. On the side, we can see that this has the 2-inch paddle meter installed. As we move to the rear of the unit, we can see that this unit has the shorter 1600 injection system. It is also in the position further away from the back plate, so this would be our downflow unit. This is the unit we are going to use for our teardown. If we follow over, we can see our meter cable go into the top of the meter cap. Using a 3/16 driver or a slotted screwdriver, we can remove the screw. When the screw is removed, we can see that we have flat sides on the end of the cable. If we want to check the meter, we can wave a magnet across the end of the cable. This should register flow on our controller. If it does, we know the cable and the control are working properly. If it does not, we want to check all of the connections from the cable through the control. If it does register flow, we can then remove the meter cap and see if we have some debris that may be clogging it. With the cable removed, we can look to removing the meter. The meter is held on by a union and a connector that goes into the valve body. If we loosen the nut on the union, we can get the meter to come off. You'll notice that on this unit, we do not have the O-ring in the meter or the flow straightener. That is within the connector. To remove the connector, we unthread it from the body of the valve. In here we can see the O-ring that seals to the face of the meter. Inside the connector, you will find the flow straightener. This redirects the flow of water to the center of the paddle assembly. As we move to the front of the valve, we can see that the cover is held by a screw. Using either a 7/16 driver or a slotted screwdriver, we can open the door. We can rotate the door open, and if we need to remove the cover, find the hinge pin and pull it up. To remove the lower cover, we have a screw on either side. Using a slotted screwdriver or the same 7/16 driver, we can remove the 2 screws. With power off, we can then address the controller. Loosening the screw at the top with a 3/16 driver or a slotted screwdriver, we loosen the screw. Once the screw is loose, we can then rotate the control out of the way. This will give us access to all of our connection points. If your unit is a metered unit, you will have the 3-pin connector. The next item is the black and the white wires. This is your supply power to the control. Pressing up on the tab and down on the wire will remove it from the control. Repeat for the second wire. The next connector is our 5-pin connector. This is the motor and limit switches for the top drive assembly. We pull this straight loose from the control. Since this is a 2-piston control, we also have wire connections for the lower drive. The black and the white wires are the motor control, while the green and the red are for the limit switch. The green and the red we can pull straight away from the control. The black and the white use the same terminals like on the bottom for power. We press down and pull the connectors away. With all of your connections free of the control, we can then remove the hinge pin. There's an O-ring on the bottom side, and then we pull the pin up. With the control removed, we can then move around to the brine system on the valve. At the top we have where our injector assembly is. We then follow our J-tube down and find where our brine valve is. We begin by loosening the nuts on the J-tube. The brass nuts on the 1600 system will use a 5/8 wrench. The plastic nuts will use a 13/16 wrench. As we loosen the nuts, we can then pull the J-tube to the rear of the valve. We can then take the cap off of the injector assembly. Using a 1/4 inch driver or a slotted screwdriver, we loosen the screws. This particular unit has a number 4 stamped into it, which tells us that we're going to have the green injectors on the inside. We should also have a screen inside the 1600 system. This should be slightly compressed from where the cap crushes down to the body. We can try to clean this with a soft brush or warm water, or replace as required. To remove the injectors from the housing, we use a large slotted screwdriver for the top part. Once this is loose, we can remove the lower part with a smaller slotted screwdriver. If we should need to replace the injector, we want to make sure that we match the color and the material. We use different colors and different materials based on what the unit is going to be used for tank size or pressure of operation. Some units, such as these gray PVC or these stainless steel, only have one color, but they have different orifice sizes for different tanks and different operations of pressure. We want to make sure that we choose the same color and same material should we need to replace any of the parts. You can also choose to get the parts as an assembly, with all seals and internal materials already assembled. You can get this in either the plastic version or the high temperature brass version. With the injector housing removed, we can move over to the brine valve. Using an 11/16 wrench in the back and a 3/4 inch wrench on the front, we can loosen the nut. We then remove the valve towards the back of the unit. We want to make sure when we're removing the valve, we do not cause any damage to the gray coating on the piston rod. If we should need to replace it, we want to make sure that we match the brine line flow control. This particular one is rated for 1 gallon per minute. So our 1600 unit, we would want to make sure we match color for color, red at 1 gallon per minute. We can also choose to use the plastic 1650 version, making sure to match our brine line flow control. If we do not have one available that matches, we can use ones with different brine line flow controls, but we would have to change what our brine refill cycle is. The 1600 system is used for tank sizes up to 24 inch in diameter. If we need to use larger diameter tanks, we would move to the 1700 system, such as this 1710 valve or this 1700 brass valve. The 1600 assembly is easy to identify as the throat and nozzle assembly thread in, compared to the 1700 where they press in. But on the 1700 system there is no screen. On the bottom side of the injector assembly, we have our regular gasket, but we also have the flow disperser at the bottom. This may be on the bottom of the injector assembly or inside the body. Make sure you only have one piece or you will cause damage. To remove the injector, grab onto one of the tabs. For the bottom half of the injector, it is easier to use a spare injector to press down from the top. This will allow you to pull the injector out of the bottom half without causing any damage to the orifice. If we should need to replace the injector, we want to make sure that we match the color and material. Both the 16 and 1700 have different colors for different flow capacities as well as tank diameters. We want to make sure that if we do a replacement, we use the same color and material. You can also choose to order the injector as an assembly. This will include your top cap, which identifies which injector, your flow disperser, and any required gasketing. If you should have a filter assembly, you will have the cap, gasket, and 2 screws. We can then move to the front drive assembly. We can see that we have 2 limit switches on the drive assembly. The red switch is our homing switch and is closer to the motor. The white switch is our position switch. Between the 2 switches, they ride on the cam below and tell the control what position the piston is in. We can see on this unit we have our blue cam. To remove the drive assembly, we follow the drive cam all the way back to where we see the link pin. To remove the pin, use a pair of pliers and pull off to the side. We can then loosen the 2 screws, one on top and one on the bottom, that will free the drive assembly and the back plate. Using a 7/16 driver, socket, or slotted screwdriver, we loosen the screws. As we loosen the screws, we want to make sure that the drive assembly and back plate do not contact the gray coating on the piston shaft. Since this unit has 2 pistons, we have a second drive assembly on the bottom. Using the same procedure, we pull the drive link pin off to the side. We then use either a 1/2 inch nut driver, socket, or slotted screwdriver to remove the plate and drive motor. We still want to make sure we watch the gray coating to make sure we do not cause any damage to it while we remove the back plate and drive assembly. With the drive assemblies removed, we now have access to our upper and lower pistons. We'll notice that the upper piston has a white end cap. The lower piston has a black end cap. This unit with the black end cap tells us that this is a no hard water bypass unit. We always check the lower piston on a twin piston valve instead of the upper piston like we would on a single piston valve. To remove the upper piston, we add our drive link pin back on and use that for leverage to pull our piston out. With the piston removed, we can then use our seal puller tool to remove the seals. We then use our spacer puller tool. This is the same tool for the 2750 as it is for the upper of the 2900. We press down on the plunger and 3 ears push out into the spacer. We pull the plunger back and we can remove the spacer. We alternate between our hook tool for our seals and our spacer tool for the remainder of the valve. As we pull out the 7th seal, we have one more spacer in the back. That is the special spacer that goes all the way to the rear. We need to use the hook tool on this instead of the spacer puller tool. As we pull this out, we can see that one edge has a bevel and the other side has a ridge. The ridge is designed to cut into the seal. With the upper piston now removed and the seals and spacers, we can move to the lower piston. We repeat what we did and use the drive link pin to help pull our lower piston out. The end plug holes in the 2900S piston assembly give you the added backwash of the single casting unit. The 2900 does not have these holes in the end cap. We can then remove the seals and spacers the same as we would on the upper piston, using our hook for the seals and the larger puller tool for the spacers of the lower, using the same procedure of pressing in the plunger in order to remove the spacer. We alternate between the hook tool and the spacer tool to remove the lower seals and spacers set. When we pull our fourth seal, that will complete removing all of the seals and spacers from the bottom of the valve. The body is now free and clear of all of the pistons, seals, and spacers and is ready for rebuild. For reinstallation, we gather the matching seals and spacers as well as pistons. For tools, we need the silicone lubricant. We also bring in our stuffer tool for our upper and lower seals and spacers. We begin with the bottom seals. Using a small amount of the lubricant, we add it to the seal. We place that into the metal end of the stuffer tool. We then place the stuffer tool into the bore of the valve and press down on the end to seat the seal. We then add the first of the white spacers. Rotating it around, we place it into the bore of the valve. We then add a small amount of lubricant to the second seal. With the second seal installed, we then install the spacer that has two sets of openings in it. The smaller set of openings should go towards the rear of the valve. So as we add that to the tool, we want to make sure the smaller part goes to the back. Once that is installed, we can continue alternating between seals and spacers till the end. With the last seal installed, we can then install our new piston. We add a small amount of the silicone lubricant to the O-ring on the end cap. We can then place the piston into the bore of the valve. You will notice that as we put this piston in, the actual end cap will sit out from the edge of the body. This will compress when we tighten up our drive assembly. We can then move to the upper piston. We start with our special spacer. The tapered end will go towards the rear of the valve. The end with the lip will go towards the front. Once that is installed, we can grab our seals and add a small amount of the silicone lubricant. We place that in the metal end, flip the tool around, and seat it within the valve. We then alternate between seals and spacers all the way to the front of the valve. When we install our last seal, we will have installed 7 seals, 6 of the standard spacers, and 1 of the white spacer at the rear of the unit. With all the seals and spacers installed, we can now install the upper piston. We add a small amount of the lubricant to the O-ring on the end cap. We then place the piston into the center of the bore, pressing down on the end cap to seat it within the body. This piston will also sit out from the body the same as the lower piston and will compress when the drive assembly is reinstalled. The remainder of the reassembly is the reverse of removal. The 2900 has many piston, seal, and spacer options. In the front we can see the plastic spacer and seal set as we used in our installation. We also have a hot water option which uses a brass special end spacer, the gold color spacers, and then the seals. We also have our higher chemical resistance seal and spacer set. For the lower piston, we also have 3 examples. The plastic seal and spacer set as we used in our installation, the brass set for our hot water option, or our chemical resistant seal material with the plastic spacers. We can notice if it is a more chemical resistant seal, as it will be denoted with a color on the outside of the seal material. For the upper piston, we have the option between the downflow and the upflow version. The downflow will have a taper at the end of the piston, while the upflow will be a square cut. We also have the option for hot water in the same downflow and upflow pistons, but we then have a brass end plug. For the lower piston, the white end plug tells us that this is a hard water bypass unit. The holes in the end plug tell us that this is for the single piece casting 2900S as we demonstrated. The brass end plug is for our hot water option, and for a no hard water bypass option we have 2 pistons. The one without the holes is for our no hard water bypass option with the upflow style valve. The one with the holes is the more common downflow style valve. Make sure to choose the correct piston seals and spacers for your installation, and always make sure to use the approved silicone lubricants on any of the seals. Good luck, and thanks for watching.